Today we're going to be talking about the gram-negative lab algorithm. It's kind of annoying because it is a lot of memorization, but there's some tips and tricks that you can use to help you remember them. So let's start off. So the very first thing we know, obviously, is that our organism is gram-negative. Why? Because we're in the gram-negative lab algorithm chart. So obviously it's going to be gram-negative. So right off the bat, okay, if we see our organism is oxidase positive and comma-shaped, there's only two things that we know it could be, okay? The two things that we know it could be are C. jejuni or Vibrio cholera, okay? These two are both comma-shaped and both oxidase positive. So the way I remember the difference between them is that C. jejuni grows at 42 degrees Celsius. The way I kind of remember this is kind of stupid, but jejuni reminds me of Bojangles. And so there's two things. So first of all, it's fried chicken, so it's actually found in poultry, okay? And also, to make fried chicken, it has to be hot. Okay, so that's the way I remember that. If it grows in 42 degrees Celsius, it's C. jejuni. Second one is Vibrio cholera, and this one grows in an alkaline environment. And the way I remember this is that it causes Vibrio cholera, right? It causes intestinal secretion through CAMP mediated increased chloride secretion in the intestine. And the intestine, it can't be acidic, right? It has to be at least alkaline or 7 pH so that the enzymes don't get denatured. So that's how I remember that Vibrio cholera likes an alkaline environment to grow. Okay, so now we look, and it's not oxidase positive or gram-negative. Well, maybe oxidase positive, but it's not. It's not comma shaped. So then we'll look at the shape of some others. So first thing we can look at is that if they are cocci, okay, if they are cocci, or might say diplococci or something like that, then we know that it's Neisseria. Okay, so in the two Neisserias that we know are N. meningitis and N. gonorrhea, right? Those are the two big ones. And the big thing you can notice here is that that's an M right here. This M, you can think of it stands for maltose, okay? So out of the two diplococci that we have to know, one's the maltose fermenter, okay? And the other one does not ferment maltose. So that's the easiest way to remember it. So when you have diplococci, you go easily. So maltose fermenter must be meningitis because that has an M. And Neisseria gonorrhea does not have the M in it, so it's not a maltose fermenter. The second category we're going to look at is that if it's something called cocci bacilli, so you have your rods, right, which are bacilli, and then you have your cocci, which are the spheres. So in the middle of that, you have your cocci bacilli. And these are kind of the miscellaneous guys, okay? So we're talking Haemophilus influenza. Okay, remember that requires 5 and X, so maybe that would be a way you could distinguish it. Okay, some other ones you might have are Pasteurella, so where you get this, cat bites. Brucella, okay, causes brucellosis. And finally, Bordetella pertussis. So these are kind of miscellaneous coccibacilli, but it'll say that in the question stem. And then finally, we have the third. So it's not a cocci. It's not a cocci bacilli. Then we know that the final one is going to be a rod, and this is kind of a long section, so I'll make it down here. It's a rod. So within the rods, the first thing we do is we check if it's a lactose fermenter. Okay? So first thing we do is we say it's a lactose fermenter. And kind of the way that I remember things that are lactose fermenters is that you're gonna be able to grow it on something called MacConkey's agar. Okay? And MacConkey's is actually not how it's spelled. I'm spelling it different. But MacConkey's agar, it has lactose in it, and it has a dye that stains for the products of lactose. So when it stains, it'll stain red. So a lactose fermenter will be red under MacConkey's agar. And the reason why I wrote this is because you have these four letters. You have the C, the K, E, E, and the S. And if you think that lactose is key, then this K, E, E is the fast guys. So this is going to be Klebsiella, E. coli, and Enterobacter. And if you have the C and S, these guys are the slow guys. So this is Citrobacter and Serratia. So let's just move up for a second. So in our lactose fermenters, okay, we have our fast guys. Remember I said lactose was key. So we start K, E, E. Remember this is MacConkey's agar. We have Klebsiella. Okay, we have E. coli. And we have Enterobacter. And then we'll also go back up and we'll say that, okay, well then if it's slow, then we're going to have the C and the S, which are Citrobacter, okay, and Serratia. So that's if it's lactose fermenting. Now we can also have lactose non-fermenting, which is if you put it in McConkey's agar, it'll be yellow. Okay, so if it's as I said, if it's lactose fermenting, it'll be red in McConkey's agar. If it's lactose non-fermenting, then it's just going to be yellow. Okay, so it won't look like that at all. And sorry, let me move over for a second. So in the lactose non-fermenting, then we have to do a test called the oxidase test. So we have to check if it's oxidase positive, and we have to check if it's oxidase negative. Luckily, if it's oxidase positive, there's only one thing you have to know, and that's Pseudomonas. Okay. Pseudomonas is oxidase positive. That's very important to know because we know it can cause disease in CJD, in chronic granulomatous disease, because those are particularly resistant to catalase-producing organisms. And then if we go to oxidase negative, then there's 3 that we have to think. So I think that there's a P in the oxidase, there's also a P in the oxidase negative one, and then there's 2 S's. Okay, so the P here is going to be Proteus, and the other one's going to be Salmonella, and then Salmonella's sister, which is Shigella. Okay, and this is pretty much the entire gram-negative lab algorithm, so let's zoom out for a second. So here we go. Okay, so as I said, so you start with the gram-negative immediately if it's off the bat. Okay, let me actually change color here. Okay, so it's gram-negative. So immediately off the bat, if it's oxidase positive, it looks like a comma, like I drew there. C. jejuni, okay, is going to be 42 degrees Celsius. Remember I said the fried chicken thing? Like, it's found in poultry, and for fried chicken, you have to heat it up, so 42 degrees Celsius. Vibrio cholera, remember, it's in the intestinal cells, so it has to have an alkaline environment to grow. Okay, that's how I remember it. If you do the gram stain, it looks like a diplococci, cocci, then it's Neisseria. It can either be meningitis or it can be gonorrhea. If it's a maltose fermenter, right, remember it has M in it, then it's going to be meningitis. If it's a maltose non-fermenter, then it's going to be gonorrhea, because those are the only 2 things that you would have, at least on the exam. If you have a cocci bacilli, which is kind of the middle between a cocci and a rod, then you're going to have H. flu. Remember, these are kind of miscellaneous ones. It needs 5 and 10. Pasteurella, you get from cats. Brucella, Bordetella pertussis. And then finally, if you have a rod, remember there's a bunch of gram-negative rods. So first we're going to do is lactose. You try to grow in McConkey's agar. If it is fast, it's going to be key. Remember, Klebsiella, E. coli, Enterobacter. And if it's slow, then it's going to be either Cetrobacter or Serratia. And just to remind you, remember this McConkey's agar with the C, K, E, E, S. Remember, these guys are the fast guys, K, E, E, and the C and S are the slow guys. And then finally, if it's non-lactose fermenting, let's just write this. If it's non-lactose fermenting, then if it's oxidase positive, we know it's Pseudomonas. It's the only thing it could be. And if it's oxidase negative, it's going to be PSS. It's going to be Proteus, Salmonella, or Shigella. And that is the gram-negative lab algorithm chart.